Hello everyone, welcome you in my YouTube channel. I am Dr. Muhammad Sirajul Faisi. Today in this video, I am going to talk about alcohols, phenols and ether. This is NCERT book unit 11. So you read it, this passage, a lot of informations here. Come to directly on classifications. Alcohols, mono, di, tri or polyhydric alcohols, 1OH, 2OH and 3OH. This is monohydric, this is dihydric and this is trihydric alcohols. So compound containing sp3 carbon and OH bonds. You see this CH2OH, CHOH and COH. So this is 1 degree alcohol, this is 2 degree alcohol, this is 3 degree alcohol, because this OH attached to carbon and this carbon attached with single carbon. Here 2 carbon, here 3 carbon. This is primary, this is secondary, this is tertiary. Again primary, this is secondary and this is tertiary. Phenol, you see this is monohydric, this is dihydric and this is trihydric alcohols. A lot of examples, their common name, just like CH3OH, all methanol, 1 carbon indicate meth and all indicate cyclohexanol and then 2-methyl cyclopentanol. Common name, you see phenol, and IUPAC name also phenol, orthocastrol 2-methyl phenol, metacresol 3-methyl phenol or paracresol 4-methyl phenols. Here you see 2OH group, this is commonly known as catechol, this is resercinol and this is hydroquinone or quinol. Practice it. Now structure and function of functional groups. This oxygen attached with one side hydrogen, another side carbon. So there is a length 96 pm of bond length of OH and bond length of carbon and oxygen 142 pm and the angles 108.9 degree. So in phenols you see little bit change, in ether this is going to increase. So you see 108, now 111, and this is important for your exams, competitive exam. Alcohol and phenol, preparations, you can prepare alcohol from alkene, you know it, you see double bonds, OH. This is the mechanism how water take hydrogens and forming hydronium ion. Now this hydrogen attached by these double bonds and forming this intermediate, and then nucleophile attack on water on carbocation and forming this, and deprotonation to form an alcohol. Second one, hydrogenations oxidations. You see BH3 equal to, this is known as diborane, giving BH2NH after dissociation of these double bonds, and then under many steps to form trialkyl borane, and then reactions with water and hydrogen peroxide forming propane 1-or. So 1 to 3 carbon, 1 to 3 carbon, here attachment of OH in many steps. So from carbonyl compounds, this is aldehyde react with H2 in the presence of palladium, will get the alcohol. This is the reductions. If you have the ether, you will get the secondary alcohol. If you have acid, then you will get the primary alcohol, lithium aluminum hydride and H2O. You see this is the acid and react with alcohol forming esters and react with H2, give the primary alcohols. Here is also this alcohols after reductions. So from Grignard reagents, This is RMGX, you know, and you know this is the polar in nature. So negative part will come at carbon and positive part will go oxygen, forming this reduct, and after water reactions it will give this alcohol. So this is the primary alcohol, secondary alcohol and tertiary alcohol. From haloarenes, you see this is halogen here, react with sodium hydroxide, sodium phenoxide and then phenols. From oleum, SO3H and react with sodium hydroxide H plus forming phenol. You have aniline, it react with sodium nitrite and HCl, benzene diazonium chloride and then phenols. If we have the cumene, this compound is known as cumene, forming cumene hydroperoxide and then hydrolysis give the ether and alcohols. Physical properties, you know this OH group forming hydrogen bonds, so boiling point is already high. So high boiling point of alcohol are mainly due to presence of intermolecular hydrogen bonding. Chemical reactions, you see alcohol has an equilifiers and forming this, and the last product is ether. So this is the steps. If you have alcohol, it reacts with H plus forming OH2 plus, and then there is the attack of another nucleophile forming this bromo products. So reaction involving cleavage of OH bonds. Many reactions were formation cleavage of OH bond. So reaction with metals, this OH, this sodium oxide, this is OH, aluminum tert oxide, this is OH, sodium phenoxide, this is OH, sodium phenoxide, this is the base, this is alcohol, base trap this hydrogen, conjugate acid and conjugate base. Now acidity of alcohol, you know, here is one donating group, here two donating group, here 3D group. You know this is tertiary OH, this is the secondary and this is the primary, you know it. So this is the base, this is the acid forming conjugate acid and conjugate base. Now you see this phenol showing the resonance, and if you remove the hydrogen then alkoxide and phenoxide. So phenoxide is more stabilized by resonance. This is the resonating structure of phenoxide. You see the reactions, you know, alcohol and acid react forming esters. Here anhydride also give the ester product along with acid. If you have the alcohol and acyl halides, you will get the esters. You see this is very common reactions in the laboratory. Salicylic acid give the aspirin, react with acetic anhydride. You see this bond will change with the ester. Reaction involving cleavage of carbon oxygen bond means carbon oxygen bonds. So this carbon and this oxygen bond, formation of alkyl halides. You see this OH and this H undergo dehydration forming alkene. You see this OH replaced by again in the presence of H2SO4. So water remove, formation of double bond. Here also formation of double bond. Here also formation of double bond. So this is the mechanisms. Ethanol take this proton forming protonated alcohol, and then water remove, carbocation will form, and then this hydrogen H plus will remove and formation of ethane. So bond breaking here and bond breaking here, formation of CO. So if you have the oxidations, so oxidation of alcohol give aldehyde, and aldehyde oxidation give carboxylic acid. This is alcohols. In a chromium oxide, this is also oxidizing agent, a strong oxygen from aldehyde. We have alcohol, here aldehyde in presence of PCC. Chromium oxide, secondary alcohol give ketone, Primary alcohol give aldehyde, secondary alcohol ketone, and tertiary alcohol alkene. Electrophilic aromatic substitutions, you see OH, nitrations at ortho and para positions. This is intramolecular, so this is intermolecular. Pancreas will give this picric acid, this is also important compounds. Now hydrogenations, you see ortho and para products. Para product always major product, you see with brominations. You see this is give the sodium phenoxide and reactive carbon dioxide and give the salicylic acid. Riemann-Triman reaction, this is most important reactions of phenols. Chloroform NOH give the intermediates and then salicylaldehyde. This is very good starting materials. If you have the phenol, reactive zinc give the benzene. Oxidation of phenol give the benzophenol. So commercially important alcohol methanol, you can prepare methanol with the carbon monoxide and hydrogen gas. Ethanol, you have these products, carbohydrates, C12, H22, and then invertase enzyme will give the glucose and fructose, and in the presence of zymes you will get the alcohols. Now preparations of ether. Dehydration of alcohol, you see, in the presence of H2SO4, in the presence of H2SO4. At different temperature, one temperature you will give alkene, another temperature you will get the ether. This is the mechanism. Here you see attacking on this removal of H2O, and then this H plus will remove and formation of ether. Williamson ether synthesis. This is most important reactions. RX and RON, NAX will form here, formation of ether. This is the mechanisms. You see, if you have alcohol, sodium phenoxide, again you have alkyl halide, you will get this ether. Now physical properties, look at here, this is alcohol, this is ether, and this is alkane. You see how much difference of boiling point due to the intramolecular hydrogen bond. Chemical reactions, you see cleavage of CO bond in ether, this bond CO in the presence of acid RX, RX. Here the CO bond, you see formation of alcohol. Now electrophilic substitutions, this is the resonating structure of ether. You see halogenations at ortho and para positions. You see this is ether. Fidelgraph alkylations, here main product, major product, acylations. You see nitrations, ortho and para products. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.